welcome to another one of my videos. This circuit is of course, Arduino circuit, which I've been working on over the last a few nights actually. I'm on night shift at the moment, and there's a lot of circuits out there on the internet that are temperature controlled fans that half work or don't work at all. In fact, the code's broken in a lot of the ones that I've seen. Well, I've actually rewrote the whole code and I've got this working now. What this is set up giving you at the moment is at below the set point, temperature wise, the fan will not be running, and it will progressively get faster as the temperature rises. So the fan speed actually follows the temperature. It's just a DC fan, and it's just being controlled by pulse, of course. The LED light that you can see there, that when the fan is off is red. When it's in the mid-range, in other words between the high and the low temperatures, it's blue, and then when it's above 100%, it will go to red. Now, on the display here, we've got our temperature, we've got the humidity, that's only there as a default because of the sense that I'm using, and we've also got the fan percentage. So, also with this, and I'll just try and do this, I have to actually pause this, I think, stand by. Also with this, I've set up automatic dimming as well, so that if the lights dim, it will go down to its lowest brightness, but just stand by. So there we have it down to the lowest brightness. That lowest brightness also alters the brightness of the LED as well. There's a bit of fine tuning needed on that, but it's getting closer. It's actually a lot dimmer on the screen than what it actually looks like on this phone. Of course, the phone's trying to compensate. And back to full brightness. Right, well, what I'm going to do is, with my trusty two hands, and I'll see if I can do it without dropping my phone, I will give you a demonstration of how this works. Currently our temperature is sitting at 25 degrees, fan at 0%. Try not to burn anything. So we're at 26. Fan has started up. And because we're in the mid-range, because I think I got it set from 26 to 35 or something, that light's gone blue. Of course, the residual heat's transferring through. And of course, the temperature's slowly increasing. And once it gets up to 100%, that light will go green. Now, I'll actually use the fan to cool down the sensor, and you should see. So the idea behind that is, where I'm actually going to be using it is I've got a 24 volt fan mounted in my ceiling space at home, with two vents at the other end of the house, and the idea behind that is to take the heat loading out of the roof. It's a reasonable size fan. I don't want the fan running full time, and I don't want it running flat out all the time either. So the idea behind this is, if the temperature is above, when I eventually set this up, if it's above say 30 degrees, the fan will turn on and progressively go up to 100% to 50 degrees, being Australia. It can actually get up to about 65, 70 degrees in the roof, and it will just give the roof some air changes. But to be honest, I'm one of these people, I like to know what's going on. I'm not going to do up a drawing for everyone. What I'll do is I'll try and give, there you go, so we're down to 33%, fan's barely running. I'll try and run through a few things on here. So for the contrast, we've got I think it's a 10k pot set through to, just stand by, yeah, so through that resistor, through the 50k, 10k pot, I'll get it right, over to the contrast input. Now the brightness, of course, is controlled from this side down here. As you can see, that fan slowed right down to 11%, so she's barely ticking over. yeah, it's a little bit hard to describe how I've done everything. I know it sounds terrible to say that, but a lot of this information is out there on the internet. For example, using the transistor to power the fan is fairly straightforward. This problem you can see right now is one I've still got to fix, which is as it's sitting around its set point, in other words 26-27 degrees, it keeps flicking between the 26 and the 27, so of course the fan keeps stopping and starting. Eventually what I want to do is have it that once it gets down to that temperature, it latches down there and stays there. So there's a diode, blocking diode across the fan just to remove any noise, or any reverse EMF, and of course the LCD display is just set up as per normal, like you find most of the others. It's a fairly basic circuit, but because I just don't have the time to turn around and do up a written circuit or something. I'm actually on day 7 of night shift, so I'm pretty tired. It's actually 2 o'clock in the afternoon here, so if I sound tired, that's probably because I am. Yeah, so there's a few things to fix up. Of course, you can see the display's had a little bit of a whoopsie, but the fact of the matter is the code works. Right, that's the main thing. As you can see, there's an LDR in the bottom there. That's given us the sensor for the light. And of course, we've got our DHT. It's only a 3-wire temperature sensor. I didn't have to use humidity as well, but I've got it there, so why not? So there we go, we're in the mid-range at the moment. We're sitting at 32 degrees, 33, 34, I think I've got it set to 35 as the maximum actually. So when it hits 100%, what I'll do is I'll actually post the code for this on the bottom of this video. The board of course is an Uno, and we're running 12 volt into this fan because this is just a computer fan. The fan I'm going to be using the roof is actually a 12 volt fan, so I'll be 24 volt fan, so I'll be running it at a higher voltage. But this is just for testing purposes. So thank you for that, and hope you can get some information off this. If it becomes popular, I might do a few more, but I'm really not someone that's got the time to sit down and draw the whole circuit out for someone, but a lot of it is self-explanatory. There is a couple of libraries included in this, which you'll see in the software as well, but apart from that, it actually works. And there we go, we dropped down to 44%, and we're looking good.